Hey guys, I hope that all of you are well. So let me show you here an awesome application. So right now we have here an FQ20 RTS fail-safe, but not a normal fail-safe. This is a mechanical fail-safe. Also, this actuator here is attached to a ball valve, a 2.916-inch ball valve class 5000. All of these setup that we have here is fail close. So no matter what, this valve will close without power. So also, there is an important feature that we have here, and it's two power supply. We have here a 120 volt AC power supply, which is a main power. Some of you know this main power as a lamp power. Also, we have a secondary power supply with 24 volt AC, but some of you will tell me, hey Debian, are you crazy? Why are you putting two power supply? It's not easy. So the reason is that some of you maybe don't have a good, reliable 120 volt AC power supply, and some of you have problem. And this is a shutdown application. You want to close the valve when you want it, not when you lost main power. So that could be an option, but you want to close the valve when your system needs it. Okay, so let me show you something interesting here. First, the easy stuff. Let me show you how this actuator close when you trigger a shutdown signal. So this is an ESD selector switch. You can trigger the selector switch and you will see in less than 5 seconds your valve go to close. Okay, so now let me open back again because I want to show you something else which is pretty cool, what I was talking before. What happened if you lost the main power? What happened? So maybe you want to close the valve because you lost the main power, but maybe not. Maybe you want to set your application, or your pipeline, your process, whatever you are controlling with this shutdown valve, maybe you want to close it after something else happened. So let me show you what can happen when you lost main power supply just here in this demonstration. So there you go. So the valve is 100% open. You also have there on the video, you can see how the valve open and close. But there you go, the valve is open, you lost main power. So what is going to happen? So in a few seconds, as soon as the capacitor lost power, you are going to see this screen red, which means, hey guys, we have a problem. We lost main power. So what is going to happen here? You lost main power, but the valve remain open, which is your main useful of this kind of actuator. Now, if you want to trigger that, you can trigger in two ways. You can cut the 24 volt DC and put out power from the active brake, or you can trigger to a ESD signal. But the cool thing here is that now, because you lost the main power supply, also, I don't know if you realize that, but you have the feedback here. So your DCS is going to have the feedback. Right now it's telling you, hey, the valve remain open. It's never closed. And also it's telling you with this light that the partial stroke that I did before was okay. So right now the valve is open. You want to trigger because your system is safe, or your seal system, your C system want to trigger for you trigger. And that's it. In less than 5 seconds you close that valve. But the last thing that I want to show you, let me bring main power so the motor can come back again. So the next thing and the last thing that I want to show you today is how it works partial stroke. Why partial stroke is so important? It's important that you know that the partial stroke you can set up on the device whenever you want. And what is important here is that there are two ways that you can set up partial stroke on the RTS. The first one you can do automatically on this device. You can set up this unit to trigger the partial stroke every year, every month, at 1, 2, 3 p.m. at the time that you want it, and you are going to have the feedback on your system, or you can come back here and see if the last partial stroke was okay. And if not, you can do something before the system demand that valve. That is the most important thing, and that is the way that you increase reliability. So let me show you how you trigger the partial stroke. So firstly, you put in remote. I just set out a trigger. So this partial stroke is very special. I just set out 2 partial stroke in one shot. So the partial stroke is going to trigger the spring, hold it for 5 seconds. After 5 seconds, we'll return the valve to open. Then is all of that happen in 30 seconds. It is going to trigger a second partial stroke, which is going to run the motor to 70%, and then bring it back after 5 seconds. If both systems happen, as both situations happen in less than 30 seconds, 30 seconds one, 30 seconds the second one, is going to just give you a thumb up and it's going to be okay. So trigger on the partial stroke, there you go, it triggered. You will see here that you can have the signal, and you will see here PVST, which means that the partial stroke was activated. You can also have a signal that the partial stroke was active. So it's going to return the valve to 100% open as soon as it meets the timeline less than 30 seconds, which meet it, it's going to tell you, okay, so let me do the second one. It's going to run the motor up to 70%, remain there 5 seconds, and then bring it back. Again, what is important here is that if you have this system in a sys application, it's critical. But if not, what it's telling you is that you can test your system and be sure that it's doing what you need to do at the right time, and it's going to be reliable solution. So finally, you see we have a thumb up, it gives you the light on, which means that the partial stroke was okay. So guys, thank you very much for your time. Hopefully you enjoyed this video, and also if you need any help from you, let us know. If you can contact Emerson, good. If not, all our impact partners there know about RTS, and all of them have inventory ready for you. Thank you guys, have a wonderful day. Take care, bye-bye.